We're going to use the periodic table to predict the most stable ions for these atoms, and then we'll arrange them from largest to smallest radius. So the stability of ions is determined by the, uh, the atoms' wantingness to achieve the octet rule. So for group 1 elements, because they only have one valence electron, they're going to want to lose that one valence electron, and they're going to tend to form a 1 positive cation. Now the group 2 elements, they're going to have 2 valence electrons, and so they'll, in order to form an ion, their most stable form will be when they lose 2 of those valence electrons, and that way they'll have the electron configuration of their nearest noble gas. Group 13 elements, like aluminum, gallium, they're going to have 3 valence electrons, 2 in the valence s orbital and 1 in the valence p orbital, so they'll tend to lose all 3 of those to form a 3 positive cation. Going from right to left, neon noble gases don't form ions, and so group 17 elements, because they have 7 valence electrons, they'll tend to gain 1 electron to have the electron configuration of their nearest noble gas. So gaining 1 electron will give them a 1 negative charge, and these will be 2 negatives, and then group 15, because they have 5 valence electrons, will want to gain 3 electrons. These don't form ionic bonds. All right, so there, just got to find these. Let's find these. Sodium is right there, group 1, so it's going to form a 1 positive cation. Magnesium, group 2, right next to it, it's going to form a 2 positive cation, losing those 2 valence electrons. Aluminum, group 13, is going to lose 3 valence electrons, form a 3 positive cation. And where are we going? Sulfur, it's going to want to gain 2 electrons. And then chlorine is going to want to gain 1. So those are your, oh, we got more here. All right, so let's go here. Potassium in the same group is going to have a 1 positive charge, and calcium is going to have a 2 positive charge, and there we go. Let me go back and match these colors up. And gallium, so those are your most stable ions. Again, it's to get that full energy level, valence energy level of full of electrons to achieve the octet rule. Now I'm going to copy this over here to get a little bit more space. Now we're going to arrange these from largest to smallest, and the anions are going to be the largest ones. And the reason is anions gain electrons, and so when you're adding electrons to an atom, so here's the let's say this is sulfur with its protons, and let's say this is chlorine with 1 more proton. So the 2 main factors here going across the period, because the shielding it remains the same, because what that means is they'll have the same number of inner electrons shielding them. So the main factor is going to be nuclear charge, which is the number of the protons. All right, so sometimes we call that Z, and then also the electron repulsion. Electrons are negatively charged particles, so when you're adding electrons, you'll get more electron repulsion. They'll tend to puff up. Electron repulsion. So in sulfur's case, you're adding 2 more. Well, let's go this way first. In chlorine's case, when you add an extra electron, it's going to repel. It's going to cause repulsion to the electrons that are already there. But in the sulfide anion case, you're adding 2 electrons to the electrons that are already there. So that's going to cause even more repulsion, and it's going to have, it has less of a nuclear charge than chloride does. So there's no compensation for that. So there's sulfide is going to be the biggest because it has less nuclear charge and more, it has less nuclear charge and more electron repulsion, both contributing to the larger radius. All right, so the largest of all of these is going to be your sulfide. And then your second largest is going to be your chloride. All right, let's move on to the cation side. Cations, when you remove electrons for the opposite reason, those ions are going to get smaller because the effective nuclear charge is going to increase. When you remove electrons, there's fewer electrons and the same number of protons attracting. The fewer electrons are going to bring them in closer to the nucleus, and there's less electron repulsion. So that will also allow that to get smaller because there's less electrons repelling each other. All right, so let me just give you, see if I can. So potassium is going to be your largest cation. Let me just see if I can do this here. So potassium, because it has the greatest nuclear charge of all of them. Well, actually, that's not true. It has the all right. It has the least nuclear charge of all of the ones in that period, and it only lost 1 electron. This is obviously, I don't feel like drawing 19 protons and electrons, but if you remove one of these, now the rest are going to be brought in. That's what I mean. So I'm going to need this space. So potassium is going to be your largest cation. Now, these here are going to be a little tricky. I don't know how you would distinguish only using just the periodic table if you were just a general chemistry student. I don't know how you would know which one is larger. So I'm going to stack, if you know, maybe you can let me know. I want to stack them on top of each other. Now the reason these are going to be similar is because these ions have an extra energy level of electrons. But so calcium is going to be bigger than magnesium. We know that. And then gallium is going to be bigger than aluminum. We know that. But the second factor is that nuclear charge. Because this is losing 2 electrons, it's going to have a much greater effective nuclear charge than the sodium cation. All right, so I don't know how a student would know. So I'm going to stack them on top of each other. So the next one would be, the next biggest will be the calcium and the sodium. Actually, let me do it this way. The sodium cation and the calcium 2+ cation. All right, and then your next one for the same reason. All right, it's not very clear. Gallium has an extra energy level of electrons, but it also has that it's lost 3 electrons. It's going to be really brought in the remaining electrons by that really strong nuclear charge by losing 3 electrons. So I'll put them together, the magnesium and the gallium. And then the last one is definitive. The aluminum cation is going to be the smallest one. And that's because it has the fewest, it has the least shielding, it has the fewest energy levels, and it has the greatest nuclear charge. It has lost greatest effective nuclear charge. It has lost 3 electrons. All right, so these are kind of like, they should be very close. So I'm not sure how a student is supposed to distinguish between those. I would say that's your answer.